Welcome to the tutorial for predicting and confirming the number of solutions in linear systems. The first thing that we have to look at when we're looking at linear systems is put both equations in slope-intercept form. And you'll see the reasons why when we look at steps 2 and 3. Step 2 is look at the slopes. Are the slopes the same or are they different? If they are different, it will result in two lines intersecting at only one point. And that's important to note, that if they're different, then only one point of intersection. And the third thing you're going to do is you're going to look at the y-intercept. And again, is it the same or different? Now let's put these steps into practice. Let's look at our first example here. We have the linear system of y equals 2x minus 3, and we have y equals 1/2 x plus 3. So if we look at the first thing is, are they both in slope-intercept form? Yes. So these ones are both slope-intercept form. Step 2, look at the slopes. Are the slopes the same? So let's look. We have 2 and we have 1/2. So no, slopes are different. Well, then we know for sure, therefore, they intersect at one point. How can we confirm this? We can confirm this through graphing. Now, if we look at graphing, we look at step 3, we can look at the y-intercepts. For this first equation, it's at y equals -3. For the second equation, it's at y equals +3. So we have two different intercepts. So let's go ahead and graph this. So I have a y-intercept at -3 to -3. So I'm going to have one there. Let's put that in purple. And I have another one at +3. I'll put that one in blue. So I know that the graph of y equals 2x minus 3, it has a positive slope of 2. So if I actually were to plug in points, if I look at a table, so I have y equals 2x minus 3, and if I did a table of x and y's, I would get, okay, we got -3 and 0. Well, I know that because there's my purple point there. I also know if I tried 1, I get -1. If I put in 3, I get 3. So this just gives me a few little points to look at. So I have 1, -1. So where's 1, 2, 3, 4, 5. Okay, so 1, -1. So I need purple because I'm looking at this line here. And I need 3 and 3. So I need that right there. So this line cuts like that. So this one is y equals 2x minus 3. Okay, let's look at my second line, which is y equals 1/2 x plus 3. So look at my x and y. If x is 0, I know that, oh, I see what I did here. This one is 0, my y is -3. It's 3, so there it was. And then I have, if I do 1, it gives me about 3.5. And if I do 3, it gives me 4.5. So I have 1 and 3.5. Oh, I need some more points up here. 2, 3, 4, 5, 6. So that'll be 6. So let's get back to my blue. I have 3.5 and 1, so that's roughly about here. And then I have 3 and 4.5, which is about there. So if I were to graph this one, so they cross about here. Oops. Let's make sure I get my line right. So if I look, they're crossing there, and I'll color that green. Coloring that green. So it's about 1, 2, 3, 4, and 5. So just by my graph, I see that they cross roughly at 4, 5. So again, that's approximate. And they intersect at 1 point only. Let's look at another example. 4x plus 10y equals 30, and 2x plus 5y equals 35. So step 1, I need to rearrange. I want them in slope-intercept form. So I have 10y equals 30 minus 4x. So I'm just going to rewrite this as 10y equals minus 4x plus 30, and then y equals minus 4 over 10x plus 30 over 10. So y equals minus 2/5 x plus 3. So that's the first one. And then let's look at my second one. I have 2x plus 5y equals 35. So I have 5y equals 35 minus 2x. So let's just rewrite that as 5y equals minus 2x plus 35. Y equals minus 2/5 x plus 35 over 5. And y equals minus 2/5 x plus 7. Okay, so I look at step 2, my slopes. I can see that the slope in the first one is minus 2/5, and my slope in my second one is also minus 2/5. So my slopes are equal. That means they're going to lie the same way. Since they're negative, they're going to both be lying up and to the left. Step 3, let's look at my intercepts. My y-intercepts, are they same or different? If I look at them here, I have plus 3 and I have plus 7. Well, they are different. So that means if I'm looking at a graph, let's extend my orange line here. So if I'm looking at my graph, that means I have one crossing here at 3 and one crossing here up at 7. So that means these lines are parallel and have no solutions. They have absolutely no solutions. Parallel lines never meet. So the linear system has no solutions. Let's look at this third example. I have 10x minus 6y equals minus 12. I have 21y equals 42 plus 35. So again, step one, rewrite. So I have minus 6y equals minus 12 minus 10x. So what does that give me? I'm going to switch everything to positive, so I'm going to multiply everything across, left and right sides, by minus 1. So I have 6y equals 10x plus 12, y equals 10 over 6x plus 12 over 6. So y equals 5/3 plus 2. So there's the first equation. Rewrite the second one. I have 21y equals 42 plus 35x. So I have 21y equals 35x. Let's make that a little more clear so it looks like a 35 plus 42. So all I did is rearrange those. So y equals 35 over 21x plus 42. So what does that equal? That gives me, if I divide each 35 and 21 by 7, then it gives me 5/3 x. Oh, 42 divided by 21, and that is 2. Oh, ho ho, what do we got here? Look at step 3. Sorry, step 2, my slopes. I have 5/3, I have 5/3. They are the same. Now let's look at my y-intercepts. I have y equals 2. Oh look, I have y equals 2. Again, the same. Also, you can tell by looking at the equations here and here that they're in slope-intercept form. They're exactly the same. Y equals 5/3 x plus 2. So they are the exact same line. So that means on my graph, I have one line here, but I have the other line is right on top of it. It's the exact same line. So what does that mean? Therefore, same line, which that means, what do we call them? They are coincident lines. And therefore, the linear system has infinite, there we go, solutions. Now let's have you try. Look at these two examples here, A and B. I have the first one, 2x plus 3y equals 12, and 2x plus 3y equals 20. And then I have 2x equals 12 minus 3y, and 4x plus 6x equals 24. Pause the video, rewrite each in slope-intercept form, compare your slopes, compare your y-intercepts, and come back and see the solutions. Are they parallel? Are they only cross at one point, or are they coincident lines? Pause the video, come back for the solution. Welcome back. And in the first example, you would have found that indeed these are parallel lines. Therefore, the system of linear equations has no solutions. And in B, you would have found that these are the same lines. They are coincident lines. So therefore, the linear system has infinite solutions.